In this video, we're going to take a look at three extremely helpful algebra properties that logarithms have that help us out tremendously in a calculus class. The reason these are helpful is oftentimes we'll be asked to, let's say, take the derivative of some really ugly logarithmic expression, but if we could somehow break it apart or rewrite it using these three algebra rules, the derivative would become much, much easier. And so we'll see that in practice here in just a minute. So first of all, what are the three properties? Well, logarithms have the ability to take multiplication and break it apart into addition in some way. This turns out to be the same as the natural log of m plus the natural log of n. And so take note that this multiplication was split and now it's addition where there's two logarithmic expressions. And we'll do examples of these in just a minute. Next up, natural log of m over n, m divided by n, would simplify to the natural log of m minus the natural log of n. Right? And lastly, we use this third property all the time. If you have the natural log of something that's raised to a power, not the whole expression's raised to a power, but just whatever's inside the logarithm is raised to a power, this power can be moved out front and become p times the natural log of m. Now, I wrote these algebraic properties just with the natural log function, but these same properties hold true no matter what the base is. It could be log base 5, log base 7, log base 10. All these properties still hold true. I just simply wrote them in terms of the natural log function since that's what we use so often. Okay, so let's practice using these a little bit. Natural log of a times b squared. Now, you might look at this square term right here and want to pull it out front. You can't do that yet because not everything is squared. The first thing I see is this times, so we'll write it as the natural log of a plus the natural log of b squared. So we broke it apart using the first property. And then after that, this will be the natural log of a plus, right? Now this 2 can come out front. 2 times the natural log of b. And you see what happened here. In effect, we expanded this expression to be lots of more individual, simpler terms rather than that one large term. Okay, here we have the natural log of the cube root of x times y. As we all know, a cube root is the same as a 1/3 power, like a square root is a 1/2 power. So the 1/3 power can come out front, and then we would have times the natural log of x times y. And then we'd write 1/3, and then this would break apart into addition, but let's be careful how we write it. If we wrote natural log of x plus natural log of y, believe it or not, that'd actually be incorrect. That's not correct. Why? What did I miss here? Well, this was 1/3 times this entire quantity, so I need to make sure to keep any quantities like that together if you expand it apart. Same thing's true with division turning into subtraction. All right. Now here, it doesn't look like there's any immediate rule. You cannot break natural log apart over addition and subtraction, but it turns out we're not entirely stuck because that quadratic inside the logarithm factors. It factors as x minus 2 times x minus 4. And so now it being that it's a product, we can break it apart. Natural log of x minus 2 plus natural log of x minus 4. Okay. Now you're watching me do all these, and so you might be saying, well, Devin, these are great properties and all, but how is this supposed to help me with calculus? Well, let me give you an example. Let's say this was a function, natural log of the square root of the quantity x plus 2 over x minus 1, and then somebody asked for this guy's derivative. Well, we know how to take the derivative of natural log of an expression. You take the derivative of the inside divided by the inside. And so if you did that, it would be correct. But that would be horrendous algebra. I mean, look at this guy. This inside has a quotient rule and a chain rule. So I certainly don't want to take this derivative. And on top of all that, I'm dividing by another fraction as well when you copy this in the denominator. No way we want to do that. But if you notice, those three rules are applicable here. Maybe we can rewrite it before we take a derivative. Okay, so all this is to the 1/2 power, so I'll bring a 1/2 out. natural log of x plus 2 over x minus 1. And notice, this isn't the derivative, I'm just rewriting f. Right, next step, f of x equals 1/2 natural log of the x plus 2 in parentheses minus the natural log of x minus 1. All right, now I'm not going to go through and take this guy's derivative. We'll do derivatives in another video, but you will notice here that if you had to take this derivative, I would much rather take this guy's derivative rather than this original expression, just because the terms are so easy. Even you could even distribute the 1/2 if you wanted to. So that's primarily what you'll have to do on like a chapter test or homework on derivatives of logarithms, is you have to break them apart using those 3 algebra rules, then proceed with derivatives after doing that.